in this problem here, we're given this binomial 1 plus 2x to the power n is equal to this expansion that goes on forever. I'm looking to find n. Well, since it's binomial, I'm going to go and I'm going to use the binomial theorem, recognizing that my a value here, my a is 1, and my b value is 2x, and n is just n. And so I'm going to start to expand this out using the binomial theorem and then start to match it up to what I know it has to equal. So if I take 1 plus 2n, the first term is just going to be a to the power n, plus, then I get n choose 1, a, which is 1 to the power of n minus 1, and b, which is to the x to the power of 1, plus, and so on, use the general term, I'm going to do n choose 2, and this is going to be to 1 to the n minus 2 times 2x to the power squared, plus, and so on. Simplifying this, well, I know that's 1. Well, n choose 1, I know that's the second term, and the second term's coefficient is always equal to n. If you're not comfortable with that, if we take a look at the binomial coefficient scenario, and if I take a look at the calculation I can do here, it's going to be n factorial over 1 factorial over n minus 1 factorial, which is then just n times n minus 1 factorial over n minus 1 factorial, well, times 1. Well, these cancel, and I'm just left with n. This is equal to n. And so this n choose 1, I know it's n, and by the formula, or just the second term is always equal to the value of n. All right, so there is our use of that. If I keep expanding, I know then that this is times 1 times 2 to the x plus n choose 2 times 1 times 4x squared. Make sure you distribute the square into both, plus, and so on. If I tie it up, I get 1 plus 2nx plus n choose 2 times 4x squared, plus, and so on. Now, if I look at my the top here, my 1 is 1. I get my 2nx is equal to 2nx, but this 20x squared is equal to this term here. Here's my x squared term. So I can say then that n choose 2 times 4x squared is equal to the 220x squared. Clearly the x squares can cancel away, and I'm only looking at the coefficients. And I'm left with n choose 2 divided by 4 is 55. Now, the easiest way I know to solve that is to go to my calculator. If it's paper 2, go to your calculator as often as you can. So I'm going to go x, math, go into probability, and number 3 here. And when I hit I want to hit, and I'm going number 2. So this says n choose 2 in my calculator. Hit enter, and then I'm going to go straight to my table. Going down the table, I can see that 11 is where my value is 55. So n is equal to 11. This is doing it graphically. If I wanted to do it algebraically, if it's paper 1 and I'm not given a calculator, my GDC, I can't use it, I'm going to then use, again, the binomial coefficient formula that we're given in our formula booklet. So I know then n choose 2 is simply n factorial over 2 factorial n minus 2 factorial, which is 55 by using the formula here. Expanding this out, this is n times n minus 1 times n minus 2 factorial, all the way down, keeps on going forever, 2 times 1 times n minus 2 factorial, which is 55. Conveniently, those cancel away. And so then I can say that n squared minus n over 2 is 55. Multiplying both sides by 2 gets me 110. And so n squared minus n is minus 110 is 0. I have a quadratic that I can factor. So 110 is 11 and 10, with 11 being negative, so they add to get a negative 1. And so n equals 11, or n equals minus 10. I know n has to be positive, and so again, n is 11 if I do it algebraically. And so I have two methods that I can do, both coming down to solving this equation here. Using my calculator, I can quickly find it, or I can do it algebraically using the formula.